And good morning, everyone, and thank you for being here. So let me first introduce about Branch, what Branch does. So Branch is a leading mobile linking and attribution provider. What exactly Branch does? Branch helps to improve the mobile app business. Suppose if you have the mobile app, it will help you to bring more user into mobile app, and also it increases the engagement with your mobile app. How do we do that? So it provides a growth platform that has two products, mobile deep linking and measurement, that helps to do that. So what is mobile linking? How does it work? So let's take a simple QR code example. Most of us have scanned QR code some point of time. When we scan the QR code, it will take you to typically mobile app. If mobile app is not installed, it will take you to App Store, and then once installed, it will take you to particular page in the mobile app. That's called deep linking. So taking user to particular page or section in the mobile app is called deep linking. So Branch makes it easier. It allows to create a custom link for your mobile content. That mobile content can be embedded into QR code. And it's not only limited to QR code. That custom link we call branch links can be integrated with email, mobile, web, or OTT ads. So the second part of Branch offering is measurement and insight. So Branch provides more insight about how the link is performing. The insights such how much users installed using the particular link, how many revenue generated that link, and which campaign performing better, whether QR code outside the mall or the QR code running on the Facebook or Twitter or TV. All right, now we know a little bit about the Branch business. Let's see how Druid helps for Branch. So we primarily use Druid for customer-facing analytics. That's the Branch dashboard. You can see the number of clicks, open, those revenue metrics, and then dashboard. Those are powered from the Druid. So then why did we choose the Druid? The first reason is the nature of the data. All the metrics are time series. So we present the metrics for some particular period of time. And this data is very critical for a customer. The customer use these metrics to decide, optimize the campaign performance, or decide how much budget we have to allocate particular campaign. So we needed some reliable time series database. Druid provides that. And it's not only metrics, that it's highly dimensional. So we have more than 100 dimensions in the data set. You can see our dashboard, filter and group by. The user do the slice and dice with a different combination of filter and then dimension. So we need some database that support a multi-dimensional. Druid supports VOLA. And then we have another requirement. We have to give the data in the real time as soon as possible. It's because when the customer integrate the branch links, they want to know whether the branch links is working or not. So to debug immediately, we have to present these metrics in real time. Another use case, when they optimize the campaign, they need the result immediately, how the optimization is working. So for those use cases, we have to present this data in real time. Druid support real-time ingestion and analytics. And then apart from real time, the customer expect the analytics should be in fast. Like when they do the slice and dice, the dashboard should load very faster. By using Druid, most of the panels in our dashboard will load within a minute. And then Branch is a SaaS-based application, so our customer base grows. The number of active users use our dashboard also increases. So we need some system support, more active concurrent users. Druid is better at handling concurrent users. And then, that's our volume. Our volume is high. We ingest around 200,000 to 300,000 events per second. So in large volume, we have to summarize the data and then present analytics to the user. So Druid handles high volume of data. Some history, we started with the Postgres. Within few months, I think few months, it couldn't meet all these requirements. In 2017, we adopted Druid. So far, it's working fine. Now we know how and why we use the Druid. Then let's dive into how we take the data into the Druid. All starts from the mobile devices. Our SDK integrated with a mobile app. When user interact with a mobile app, the SDK will send events to using our event API. I will send events. The event API on the server side will collect all the events from the mobiles and then first land into Kafka. Then it will go through the business processing pipelines. That's where all the metrics inside gets added to the each event. Once the message get enriched, the message will land and again Kafka in protobuf format. So now the event is ready for analytics. So to get the data into Druid, we have two parallel pipeline. The first one, real time. Real time is to take the data as fast as possible, and then we have parallel pipeline batch that will ensure accuracy and completeness of the data. And regarding the real-time pipeline, we use the Flink. Flink is the streaming framework. Flink takes the data from Kafka in protobuf format and convert into JSON format. And protobuf format is nested structure. We need to flatten that. So that also done in the Flink pipeline. So we don't do any aggregation in the Flink pipeline. It's just a transformation to protobuf to JSON, nested to flatten. Those JSON data, again, we put it in the another Kafka cluster. We use one table, one topic per data source in the Druid. So for each data source, topic combination, we will be running one supervisor in the Druid. That will be responsible for pulling the data from Kafka and then ingest into Druid. So the entire pipeline, maximum will take 1 minute. From the event happen in the mobile, the user can see within 1 minute that the metrics, they can see it in the dashboard. So sometimes the message will get the delayed data, or the lag on the real-time pipeline will increase. So after certain time, we reject events from the real-time pipeline. That's where the batch comes in. So the batch takes complete data to the Druid. So we first take the data from Kafka and put it into our data lake. Our data lake is Iceberg data lake. So we ingest everything in Iceberg, partitioned by hourly. Then we launch the Spark, hourly Spark job that will take data from Iceberg and convert it again into JSON format, right into temporary S3 storage. And then we have our Airflow sensor operator that will submit indexing job to the Druid. And then Druid will launch the Peon. Peon is responsible for ingesting the batch data. That will launch MapReduce job in EMR. We don't use the native thing. So we use MapReduce job that is running on the EMR that will aggregate the data and then finally put into the S3 deep storage. So the data is stored in the Druid 2 years. So now the data is in the Druid. Now we see how we get the data out of the Druid. There are 3 primary channels. One, the customer. Customer will come to our dashboard to see that report and do the self-servicing analytics. The another channel, the customer systems, they use programmatically if they want to pull that Druid data. We have the public-facing query API. And then finally, our internal users inside the branch, they use our BI tools. Let's take how the flow works. If you take the branch dashboard, that will connect to microservice. The microservice will submit the Druid native JSON query and then pull the data. The microservice does more. It does the data blending. The reason we need data blending, when the request comes from the dashboard, it will have dimension and measures. The measures might be belong to multiple fact tables. So we need to pull data from multiple data sources from the Druid. So the microservice will look into find out, hey, what are the fact tables I have to query, and then it will separately frame the queries, and then parallelly submit the individual query to the Druid and get back the result. And then we load it to in-memory SQL database. And then we do the final aggregation. And then aggregated result will send back to the dashboard. And then Query API also does the same. You reuse the same microservice. And also in this layer, we do the caching. We have two level of caching. One is first level. In the microservice, the unified requests we get, those requests and response are stored in the Redis caching layer. And the second level caching, Druid. Druid support the query level caching. We use that one. So both will share the same Redis cluster. Finally, let's see how the internal user will query the data. We use two tools. One is Ternilo. It's just pivoting tool. The user can do the slice and dice very quickly, and then debug the data in the Druid. And then if they want charting or dashboarding, we use the Looker. Looker provides connector with the Druid using JDBC layer. And in terms of query pattern, most of the queries are grouped by around 10% are top-end queries. And then the data stored in the Druid over 2 years. Some complex queries like a user do year over month, quarterly. Those are the common queries we'll get. And we heavily use the hyperlog log to get a unique user account across the dimension. That's all. And I will take over from now.
Thanks, Ramesh, for introduction to Branch. So now let me dive deeper into how we run Druid, actually, how we package, how we deploy, and all wonderful optimizations that we did so far. So just to give you some idea about our cluster size, this is one of our customer-facing cluster. It's like one router, 4 brokers, 3 coordinator overlords. For historical nodes, we have 100 that's split into 2 tiers. 70 of them are backed by SSD for performance, and 20 of them, for cost reason, are backed by just simple EBS. And we have 70 middle managers to handle our real-time traffic. And to manage all of this, we have to create like 5 Zookeeper nodes. So we package Druid, like we use official Druid distribution, as probably everyone else. We put all jars, all plugins, everything that we need to it. One thing that we did differently, when we upgraded to version 26, we had to upgrade our like HLL plugin. And problem is, latest Druid version uses latest Apache HLL, which provide unstable results. So like every time you query Druid, you have different values. And even our customer has a very clear idea, it's not a real value, it's approximation. They really want this value to be stable. So we have to implement kind of backport plugin that can still run older version to not impact our customer. Also, for each Druid node, we have Telegraph and Fluentd installed. So we use Telegraph to publish metrics, both Druid level and OS level. This is how we can create dashboards and alerts. And we use Fluentd to stream query logs in real time. Let's go to this one. So as I mentioned, for each Druid node, we have Fluentd installed that actually looking on query log file. And once we have a new line, it sends data to Kafka. We have a simple Flink consumer that puts data to S3 in a table. So we can query it with Trino in real time. And why we need it? It's very useful in cases when we have some performance degradation on our cluster. And using this queries log, we can identify very fast, like, is it a just bad day for our cluster? Maybe our clients all of a sudden decided to create the end of year report just today. Or maybe we have data scientists or API people who just forgot to add their data filter, and they work in with all data sets. If we don't see any evidence of this, we can continue to investigate and see what is the problem. So as you can see, for this query, we gather all metrics about query, and also we gather customer unique identifier. This is a way how we can identify is it just one customer who did it. Next is deployment part. We deploy Druid to on-demand EC2 instances. We use Salt Package Manager for this. And talking about strategies, how we deploy. In most cases, we use like in-place upgrade. So whenever it's a config change, we just create new distribution and deploy it to the same EC2 nodes and just restart nodes one by one. But for major upgrades, when we need to shut down Druid, there's another strategy that I would actually call like, I hate to work on Sundays, or in more technical terms, it sounds like relaxed blue-green deployment. The problem is, at branch, if you want to shut down Druid even for a few hours, we need to communicate to customer to avoid any impact. And also, we need to do it only on a day where traffic is the lowest possible. And of course, it's Sunday. And when I did it last time, I remember cluster stopped responding after 5 minutes. I did update. So, and after rollback, I had a question from my manager asking like, okay, what will be the next Sunday? You will try it again. And this is where I realized that we need a better idea here. So I was playing around with Druid, and I realized that actually it's possible to do blue-green deployment in a relaxed way, at least for our use case, where you can spin up read-only replica with like new configuration or new version that you need, but you can share same database and S3 as long as they compatible, of course. So in this case, we were able to switch traffic on production between different clusters to check for performance and any unexpected error. So we were very confident when we upgrade our primary cluster. And as a result, now I can do upgrades on weekdays. So let's talk about optimizations that we did. So one problem, you probably also hit it, it's a cardinality. So some fields can have very high cardinality, like in our case, when customers were onboarding branch, they were just playing around with our tools, and sometimes they were submitting random data, like random UUIDs, random numbers, and as a result, data for this customer had like very high cardinality, and it impacts everyone else because we split our data source only by events, not by customers. And on our site, we did kind of research, and we realized that we can apply famous Pareto rules here, because in general, customers are really interested in this like 20% of data that provide 80% of insights and valuable information they need. And they don't care about this long tail of other values. And actually, if they do, we have another product that can cover this. So on our site, what we did to protect cardinality, we set up some rules by data source, by customer and field. And every day we check if number of distinct values by this combination is higher than the limit. We actually retain only top n values. And we update everything else with just word other, so that we can put it in just one bucket. So as a result, now we ensure that high cardinality data from one customer will not impact our Druid. And as you can see, our data size reduction is very small. It's like 1%, which means that this does not impact day-to-day operation for our customer, but at least we are protected from any spikes in cardinality. Daily rollup, I think it's also some technique that a lot of people use with Druid. So we started with granularity of 15 minutes. However, we realized that really our customer need hourly data just for a few days. And when we talk about like week ago, months ago, they always need daily view or even higher. So we implemented a simple job to just get data from Druid, roll it up based on our rules, and just back. The only problem we had here is how to handle time zone, because on Druid it will be UTC always, but our customer might want to see data in their time zone, and this data can be scattered across multiple UTC days. So as a result of this, we achieved around 40% data size reduction and 10% query latency improvement. Last but not least, it's the data partitioning. That's my favorite one because it did the most impact. So as I mentioned, our data sources are not split by customer, just by event, which means that heavy query for one customer will definitely affect everyone. And solution is simple, like do partitioning, it's there, it's on Druid, just do it. But we faced multiple challenges with that. As Ramesh mentioned, we use EMR for ingestion, and unfortunately, multi-dimensional partitioning was added to EMR only like in version 26, so we had to upgrade first, and it was a challenge by itself. Second problem was how to identify another partition, because problem is some customer can have a lot of data, much more than one segment can fit. So we have to add another column to do multi-dimensional partitioning and fix skew problem. So for this, we realized the best option is just to create another column, put some random values, and this fixes the problem. And short sync, it was an interesting one because we use EMR some way in this implementation for version 26. Even when I worked with 1 day of data, it needed like 1 terabyte of HDFS data that almost killed cluster in production. Good thing, there is a simple flag like assume group that you can set to false, but problem is here on the flip side, you need to do same grouping on your side to avoid problem with segment distribution. So as a result of this, we have 2x query latency improvement across most of data sources. And we already reduced our cluster by 15%, and we are going to do like 30, 40, maybe 50, who knows. Okay, just summarizing what Ramesh was talking. Like our current scale, we ingest around 20 billion raw events. Total size is 600 terabytes. We serve around 600 to sometimes 1 million query a day. And query latency across all data sources, P90 value is around 225 milliseconds. So and what next? We are going to look at native ingestion. Like we want to use power of Iceberg. And as we have Iceberg data sets, like why we need this EMR ingestion anymore. But this is our like first thing. Another thing, we are looking on how to update our data models, make it better, reduce number of dimensions, so it's like easy to use and it's less costly. And third thing we are looking at is how to make our data mutable, so that in case if we need to fix data for just one customer, we can easily do this.